Hi, Nithya. I looked these problems over, and number three is right about the second fundamental theory of calculus. You did that just right. Number four and number six are wrong, and I'm going to talk to you about these two. So let's look at number four. So we're taking the integral of this, and you actually did it like it was the integral of x dx times the integral of the square root of x squared plus 2 dx. Sort of like that, because you have the x squared over 2, and you have the x squared plus 2 to the 3 halves times 2/3. But that's not quite right. So I don't know how they're teaching this, but a pretty straightforward way is to do what's called a u substitution. So we're going to set u equal to x squared plus 2. So du equals 2x dx. So x dx equals 1/2 du. So this will allow us to substitute for this under the square root sign, and this equaling this will allow us to substitute for x dx. So over here I'm going to write our integral with the substitution. It is the integral of, x squared plus 2, we're substituting u for that. So it is u to the 1/2. And now we're substituting for x dx. X dx equals 1/2 du. So this is 1/2 du. So that's our integral. And that clearly equals 1/2 times u to the 3 halves over 3 halves, which is 1/2 times 2/3, and then plus c, of course. So the 2's cancel out. So we have u to the 3 halves, 1/3 u to the 3 halves, plus c. Now we substitute back in. U is x squared plus 2, so it's 1/3, 1/3 x squared plus 2 to the 3 halves plus c. So see if you can write that out. I'm going to erase this in a minute, but you have it on a video, so you can go back and look through it over. But for this kind of complicated thing, the main thing to look at is x squared plus 2. We're going to have the derivative of x squared plus 2 to be able to do the integral. And in fact, the derivative of x squared plus 2 is 2x. So here that x dx is going to be part of the derivative of x squared plus 2. So that's how we're going to do the substitution. We're going to make u equals x squared plus 2. So du equals 2x dx. And 1/2 du equals x dx. So now we substitute for square root of x squared plus 2. We now just have square root of u. And for x dx, we substitute 1/2 du. Now the integral of 1/2 u to the 1/2 du is fairly straightforward. That's just power rule. That's 1/2 u to the 3 halves over 2/3, which means over 3 halves, which means times 2/3. So the 2's cancel out, and we have 1/3 u to the 3 halves, and we put back in what u equals, and there we go. So, so you do end up with some of the key things, right? The x squared plus 2 to the 3 halves. The one mistake here is that somehow that x squared is part of it is not. We don't do these like they're separate integrals. We have to do them that way with a U substitution is really the way they usually do that. I don't know the way the teacher is teaching you, but this is how you do this one. I'm going to show you how to do number 6, which is a similar problem. And we may want to spend a little time each Wednesday looking at some calculus because I'm not sure how well your teacher might be teaching you these integrals, and I want to make sure you learn to do them well because they're really not that bad if you're taught how to go through them, and I really want to do that for you. Okay, so now we're going to go on to number 6. So this is similar. So we look, our U substitution is going to be for this one, because there's that expression raised to the power 3 that makes this complicated. So we're going to say U equals x squared plus 1. So then we got to figure out what du equals, 2x dx. Now we see an x dx here, but we don't have a 2, so 1/2 du equals x dx. Now we can do a complete substitution, because u equals x squared plus 1, that's that. And we have x dx equals 1/2 du, so there's x dx. So now we can do a complete substitution. Let me do that up here. We have the integral from -1 to 1 of x squared plus 1, which is u, so it's u to the third. And x dx is 1/2 du, so I'm going to put the 1/2 here and the du here. Now the limits are x equals -1 to x equals 1, not u. So we're not going to substitute in until later on when we get our x's back. For now, we have u, and we're going to do the integral using u. But we're going to substitute the x back in before we evaluate these two limits, x equals -1 to x equals +1. So we know the integral of u cubed is u to the 4th over 4. So we have 1/2 times 1/4 times u to the 4th plus c. And we're going to evaluate it not at u equals -1 to +1, but at x equals -1 to +1. So we got to substitute back in before we do the evaluating. So let me erase this. You can always go back on the video and look at this later. Let's actually, let me leave what we said u is, because we're going to substitute back in and we want to make sure we do it right. So we have u to the 4th, that is in fact x squared plus 1 to the 4th, 1/8 times that. And we're going to evaluate that now. Now we have our limits for x, so I don't have to know what x equals. We're going to evaluate from -1 to 1, x squared plus 1 to the 4th. And then we're going to take 1/8 of that. And of course, plus a constant. So let's try 1. 1 squared is 1, plus 1 is 2. 2 to the 4th is 16. 16 over 8 is 2 minus, let's evaluate this, a -1. -1 squared is +1. +1 plus +1 is 2. 2 to the 4th is 16. 16 over 8 is 2. So that, in fact, is 0. Okay. Let me see. Let me make sure I did this right. Yeah, there we go. Okay, so that should be right. The integral is 0. So I'm going to get this video made and get it over to you so you can have a look. Anyhow, these more complicated integrals that are more easily done with a substitution, and the main thing to know when you can do a substitution is you're going to have the derivative of this x squared present. And the derivative of x squared includes an x dx, so that tells you that you're going to be doing a substitution. So we can talk about this more on Wednesday, but I appreciate you sending me this so I could help you out with these.